Welcome to Brain Vision.
After reading the problem, we know that the object we are studying here is a spinning ring with inner radius of 25 millimeters and the outer radius is 58 millimeters. Also, we are told that the linear velocity of this ring is a constant. It's 1.25 meters per second. Now we see that they have different units here. Here we have meters and here we have millimeters. We want the unit to be same to do the calculation. So I just changed these two to meters. You can also change the meters to millimeters. It depends on which one you prefer. Now we start to see the problems. For part A, we want to know the angular velocity. We can regard the CD as rigid body. So according to equation 9.13, on the textbook, it's V equals to R multiplied by omega. This equation is very important. So let's remember this. V is linear velocity, which is 1.25 meters per second, and R is the distance of the points from rotation axis. Considering the geometry in this problem, R is just the radius of a part of the track on CD, and omega here is the angular velocity desired in this question. Now we know all the variables of this equation. We can write this as omega equals to V over R. And for the innermost part, we know that R here is just R inner we knew before. So we can obtain omega in equals to V over R in, and plug in all the numbers are given in the problem. And do the calculation carefully. We get 50 rads per second. And the same for the outermost part. And the R here becomes R out. And omega out equals to V over R out here. Also plug in the numbers again. It's 5.8 multiplied by 10 to the negative 2 meters here. And after doing the calculation, we get 21.55 rad per second. So these are the answer for this question. For part B, we want to know the total length of the track. It looks like it's tricky. But if we think about it, we will find this length is just only about linear velocity and time period. Now let's recall what is linear velocity. Assume that this is our CD, and we have a small bug stuck in the CD here. This is where it stays at initial time t equals to t naught, and after a time period delta t, let's say this is the unit time, the bug moves to this position. So here t equals to t naught plus delta t, and during this time, unit time, the disk spins and carries the bug without sliding. The arc length that the bug traveled in unit time is called linear velocity. Total arc length it travels during a time period t. This is a long time period, not unit time. So the displacement is t multiplied by v. This v is linear velocity. Hence, if we want to know the total length of the track, we only need to know the linear velocity and total time interval, which are all given. T is 74 minutes here. And we want it to be in seconds since our velocity is in meters per second. So this equals to 74 minutes multiplied by 60 seconds per minute. It's about 4,000 seconds. And so the total length L over time period t is v multiplied by t, and plug in the numbers again. We will get about 5,000 meters. So this is the total length of the track. Now for part C, we want to know the average angular acceleration during the whole 74 minutes. At the beginning of the problem, it said that the track spirals outward the rim, so it moves like this. Assume this is our disk. So it moves like this. And we can see the initial angular velocity is omega in, and the final angular velocity is omega out. And it's easily see that omega out minus omega in is just how much the angular velocity changed over time t. So the average angular acceleration over time is how much it changed over time t. And plug in the numbers and do the calculation, we will get a negative value. This means that the CD spins slower and slower over time. And this is the average angular acceleration over time.